Hey stats class, we're going to look at how to do some hypothesis tests for means in this video. So I've got Desmos right here. So for a hypothesis test for means, we are using the t-distribution. You'll see a lot of hints to that as we go through here, but you do need to understand when you use t and when you use z. So when we're talking about means, we're going to use t for confidence intervals and a hypothesis test. When we're talking about proportions, we're going to use z, the normal distribution. So TDIST is going to be crucial for you to understand that when you're doing hypothesis testing for the mean. All right, when I'm looking for critical values in the t-distribution, I'm going to use TDIST. All right, open the parentheses, the degrees of freedom is one less than the sample size. So a sample of size 27, I have 26 degrees of freedom. All right, and now this wants to know shift and scale and all that stuff. Go back and look at the videos from confidence intervals if you want to learn how to use that for different values, for different types of critical values that for confidence intervals. But for this, just critical values in the hypothesis testing process, we don't need a shift or a scale. Okay, we do need to use bounds for this because these are values on the number line rather than areas. And what we need to understand is we have to make sure that we select the right region based on the information given it. So this is a right tail test, so I'm going to use right, and alpha is the area in that right tail. So that's this number right here. So I'll put 0.01, and then there is I always like to drop it down here, just in case we need it to more decimal places than they provide. So this is going to the thousandths place, so 2.479, so that's plenty. If they ever ask it for any other place values beyond 3 places, you would need to use that drop-down menu so you can round it to further places, all right? But 2.479 is what's needed here. All right, now let's look at what the rejection region is. So this is our right tail test. So if I were to zoom in on this, I'm going to click this little zoom button. That's what we just found. The rejection region is the area in the right tail beyond this 2.479 number and infinity technically. So it's all numbers bigger than that number. So there's the greater than symbol. That means all the numbers, like this is the t-axis, right? And these are all the t's from here up, all the t's that are bigger than 2.479. So I'm going to select that one. 2.479 goes in there again. So whatever we got here will go right here for a right tail test again. I think of the order symbol as kind of like an arrow. So it's pointing to the right, a right tail test. I move my head out of the way. So that's all we're doing on a question like that. All right, now it's a two-tail test. So if it's a two-tail test, the only thing that's going to be different is now I'm going to select outer, right? Because if you can see, let me move this down, zoom in a little bit more. Now these areas in the two tails are both shaded. All right, if I select inner, like if I was doing confidence intervals, I would do inner for those values. But since I'm doing outer, let me do inner, like 95% confidence. That's kind of like what we are used to from the last section. But now I'm doing outer, and this area is now going to be, alpha is typically a small number. It's 1 minus the confidence level. So it's a very small number in this case. All right, make sure you get your degrees of freedom right. Our degrees of freedom here is just going to be 6. All right, and the critical values, because it's a two-tail test, there are 2 critical values. Again, I have to zoom way in for you to see it because they're so close to the t-axis there. But there are these 2 numbers right here. So negative 3.707 and positive 3.707. So put the commas in there. Make sure you put the commas. If you don't, it'll mess those up. All right, these are outer, so they are all the things below negative 3.707, all right, on that end. And then if you scroll way over here to the other end, it's all the things to the right of the upper value. So it's not, it's not this one, it's not between them. It's all the stuff below the lower one and above the upper one. So we're going to type those same two numbers again. Just make sure you get the negative one in the one that has the less than, and the positive one in the one that has the greater than. Okay, so that's the procedure when we have a two-tailed test. If it was a right-tailed test, so, a left-tailed test, be similar to what we did for that one. We would just select left, right? And then we can see the area in the left tail. Make it a little bit bigger. We can see the area in the left tail is what gets shaded in that case, and it'll find the critical value down there. All right, now let's actually walk through the process of a hypothesis test about a mean. So when you see the wording like this, like claim equals this, mean equals this, that's a hypothesis test about a mean. Claim and mu, give it away immediately. So equality, remember equality goes in the null hypothesis, so that means we want the mean equals 52,100 to be the null hypothesis. So this is the only one that has that, and others have some type of other order symbol. So that's the one that we're looking for. And then after that, it wants to know what is the value of the standardized test statistic. So I'm going to bring this back, turn this off for a second. That is just the z-score, in this case a t-score, but it's the z-score process. It's a measurement minus its mean divided by its standard deviation, just like it was way back in the beginning of the semester. So I do division first here, so I did division, and then it's the measurement, which is, in this case, it's a sample mean, so it's the 50,849 minus the mean. The mean is the claimed population mean. Remember, the mean of the sample means is the population mean, so that's why this fills the role of the mean, since they're both means. But this is something from the data set, and this is the mean of those things. So the mean of the sample means is the population mean. So that's the reason why this mean is the one we subtract. So it's the one that follows the minus sign. So 52,100. And then the denominator is the standard deviation of sample means. Okay, not this standard deviation here. The standard deviation of the sample means, which again we studied earlier in the course, is this standard deviation divided by the square root of the sample size. So the 1900 divided by the square root of n, and n is 16. All right, so there is my standardized test statistic. We typically round this to 2 places because it's like a z-score, and the z-tables are rounded to 2 places. But it is technically a t-score, and sometimes they will have you round these to more than 2. So just be careful, just make sure to pay attention right here. So negative 2.63 is what I'm getting. Negative 2.63. All right, and then what is the critical values? This is where the TDIST is going to come into play. So critical values, when you're doing a two-tailed test, that's the alternate hypothesis, will tell you which of these outers, left and right, to use. You're going to use either outer, left, or right for these. For a two-tailed test, like a not equal to symbol, you're going to use outer. Okay. Now, our degrees of freedom is 1 less than the sample size, so that's 15, and our alpha value is 0.05, which I already have. Right, so there are my critical values. There's 2 of them, so I'm going to put in there with a comma rounded to the 3 places. All right, these critical values will determine if we're in the rejection region or not. So I'm going to click, let me check my answer, and then the conclusion. So you've got a test statistic, you've got critical values. So I always encourage you to turn this on and zoom in around it, and then plot your test statistic. So my test statistic here was negative 2.63. Right, you can always copy this and then open a parentheses like you're going to plot a point, because this is like a point on the number line. Paste that and then put comma 0 to put it on the x-axis. And then you can see that's my test statistic, and it is in the rejection region. So if you turn your t-distribution on, zoom in around it with these things that you use to construct your critical values, you can do the test statistic, the critical region method, and see if you land in the rejection region. Because I do land in the rejection region, that means I am going to reject. Right? Rejection region, reject. And if you reject, the null hypothesis. If you land in the rejection region, it's because there's enough evidence to reject the null. Okay. Oh, we got to be careful. That's right. You got to be careful with what's the claim. So the claim is equality. So the claim is the null hypothesis. So we are rejecting the null. There's enough evidence to reject the null. Okay, so be careful with that. Make sure you're reading what the claim is up here in your setup, right? So that was where the claim was. So we're rejecting the null, so we're rejecting the actual claim here. All right, just for the practice, let's do one more. This one has us actually do the setup. This claim is strictly less than. That's the alternate hypothesis. So that's the mean is less than 4715. All right, once you have the claim that you're given, once you have that, the alternate is going to be the same parameter, so it's also going to be mu. Flip this around, so it's less than. Flip around, I'll have a greater than or equal to. You've got to have equality in the null, and then this, whatever number this is the same thing you'll use for the null and the alternate. So there's that setup. Find the test statistic. All right, that's the same thing we did here, but just with this new information. So this number right here was the sample mean. So I'm going to replace it with my sample mean of 4817. All right, this number was my claimed mean before. There's the claimed mean is 47. All right, and then the standard deviation is 5389. So I'm putting that down here. And then this divided by the square root of my sample size, which is 54. So I'll put the 54 right there. Okay, so there is my test statistic. I'm going to copy that. I'm going to put that right there. For the purposes later on, we still have to get the distribution right. But the test statistic is this rounded to 2 decimal places. That'll be 0.14. All right, so there's my test statistic. The p-value. The p-value is the area in this distribution beyond your test statistic, not beyond the critical numbers. That's just alpha, but beyond the test statistic. So I'm going to use this number in the correct t-distribution. So this is 54, so I need 53 for the degrees of freedom. All right, this is a less than, so I'm going to do a left, and a p-value is a probability, and probabilities are area, so I need area to find the p-value. So the p-value is the area, in this case, to the left of this number, so 0.139. Or 0.14, which is what I did in the last problem. I'm doing 1.39 just because that's where a 0 is. So I'm just rounding it to one place. So there's my p-value. It wants it to 3 places, so 0.155, so 0.555. So there's my p-value. All right, and then we can use, like we did on the last problem when we did the test statistic, in the critical regions and solve that the test statistic was in the critical regions, or the more common thing to use is the p-value method. So because the p-value is significantly bigger than alpha here, I'm going to fail to reject. If I fail to reject, it's because there is not enough evidence at this 5% level. And this is what I was talking about before. You got to look at what your claim is. The claim is the alternate. So there is not enough evidence to reject the null. But that means support the alternate claim. So you've got to be able to understand how to work that actual claim into the conclusion.